right, so now let's look at example 3. Example 3 asks you to find the area between two numbers. So let's put those two numbers on our normal curve. One of them is 1.62, which would be right about here. The other one is negative 1.35, should be somewhere over here. Now it's asking us to find the area between those two numbers. So remember, this is the third case that we gave you. To find the area between, you look them both up and you subtract them. So we want to look up first, let's look up the 1.62. So if we go to our chart and we look up 1.62, this would be 1.6. You go over twice. Let's see, 0, 1, 2. So 1.62 is 0.9, let's see, 9474. Okay? Now the other number we're looking up is negative 1.35. If we go up here to the negatives, negative 1.35, 0, 1, 2, 3, 4, 5, is 0.0885. So what we need to do is go back to our chart, our curve, and we need to write those down and subtract them. So 1.62 was 0.9474. And you always want the smaller one second, so the one on the left. Negative 1.35 is 0.0885. So we're going to have 0.9474 minus 0.0885. When you subtract that, you get 0.8589. So what that tells me is that 85.89% of my population lie between those two numbers. Now, example 6, part A is asking the same thing, but if in a different way. This one asks it as a probability. They say, what's the probability that Z lies between 0 and 2.53? Z's in the middle, so I'm going to draw the same type of picture. I'm going to put 0 here and 2.53 over here. And they want to know what is the area, the probability is the area here that's between. So when I look these up and I subtract, I'm going to get the answer the same way I did on example 3. It's just asked a little bit differently. So we're going to look up 2.53. Let's go to our chart. 2.53 is going to be 0.9943. And then we're going to look up 0. Now 0 is right here. It's 50%. Of course, it's half of the curve. So let's write that over here. So 2.53 was 0.9943 minus 0 was 0.5000. That gives you 0.4943. So that tells me that 49.43% of my population lie between 0 and 2.53.